Thank you very much, ladies and gentlemen. I'm Honorable Babu Owino, Member of Parliament, Embakasi East Constituency, and today I would like to take the university students through a topic called calculus, which is in mathematics. Calculus is studied by various degree courses across the world, and we decided to come up with this as a public demand from various students in Kenya and students across the globe. I hope you'll enjoy your mathematics lesson today on calculus. Number two, I would like to take this opportunity to send condolence message to my friend, a friend who was so close to my heart, a Bailey ally, who just passed away the other day, Abeni Jachiga. May your soul rest in peace. Till we meet again, this class is in memory of Abeni Jachiga. I would like also to take this opportunity to apologize on behalf of the students, the comrades who can't access our lecture today because of various reasons, because of extenuating factors, probably because they don't have smartphones or airtime, or because they are busy. So I hope God will bless you so that at least you get one. Thank you very much. Enjoy your class. So today our class is about mathematics. And we'll deal with calculus. So in calculus, this is a little bit advanced. For our KCSE students, you'll bear with me. This lesson is a special lesson for the comrades, but you can also learn from it because you are soon coming to the university, and I will make sure that you join the university. I will make sure that you pass your examination. And very soon you'll meet the advanced calculus. It's not news to you. We did calculus in high school, and you are still doing it now, but this is a little bit advanced, and you will see that it is easier than the calculus you are handling as we speak. So calculus, this is a branch of mathematics that deals with changes in substances, changes in quantities. So basically, when we are studying calculus, we have different branches of calculus also. The two main branches of calculus that we have is differentiation and we have integration. These are the two main areas that we'll study under calculus. Differentiation is the rate of change of a substance, rate of change of quantities, rate of change of a function. So differentiation is the rate of change. Is the rate of change of a function. While integration is the determination of a function having given the rate of change. So class, we want to know the reason why we need differentiation. Differentiation we want to know the reason why we need differentiation in life. And differentiation came up as a result of uncertainties in life, the different changes that occur in life, majorly in production. For example, in a market when there are uncertainties, that is where now we come up with differentiation to solve the uncertainties. So uncertainties can can be brought about by different factors in the market. Now, when we talk about uncertainties in the market, we will talk about, I'll take you back a little bit about how things began during the 17th century. So in the 17th century, we had the economic growth, and we had the population growth. So during this period, we had somebody called Thomas Malthus. So the population was growing, but during this period, as the population grew, there was enough food, there was enough food for the growth of the population. So actually things were just normal. And during that time, Kenya could have probably had a population of around 500,000 people. Right now, you see we are approaching around 47 million people. So during that period, the food that was being produced was just sufficient for the people. So Thomas Malthus was studying. He came up with a book studying how the population growth was varying with the economic growth. And he came up with, in the Cartesian plane, he came up with some graph like that. So during this period, from here to here is what we call the Malthusian trap. As you can see, as the population was growing, the economic growth was insufficient. There was sufficient supply of food to feed these people. They were directly proportional. Then at this point, people now felt that there were certain issues that was making the population to be controlled. But population started increasing rapidly. With the increase in the population, we had to do something about the economic growth. So because of the economic growth, we had to come up with some controls and measures that were put in place. So during this period, people wanted to break up from the Malthusian trap. So at this level, there were some theories that came up to control the market. So that is where we came up with communism and capitalism. So at this point, we want to look at briefly, I will not go into details, I just want to tell you how we will need differentiation in controlling the uncertainties which is brought about in the market. So communism is a production where the government is in full control of the factors of production, And in communism, we had somebody called Karl Marx. Karl Marx wrote a book called Des Kapital. This book basically talks about communism. The ideology in communism is called the Marxism. That's why some people here in Kenya, they call themselves the Marxists. It is from the Karl Marx school of thought, the ideology. So communism advises that the government should control production. That if we produce X number, if the government wants to produce, for example, 1 million bags of maize to feed Kenyan citizens. It's an example. It might not be sufficient. It's an example. To feed Kenyan citizens. Then it will communicate strictly to the farmers and tell them that farmer X, a farmer from Nyanza, to produce 200 bags, a farmer from Central to produce 200 bags or 300, a farmer from Rift Valley, a farmer from different farmers from the country to produce. And the farmers will have no option but just to say, yes, that is the exact number of maize bags that we must produce. Communism is controlled by the CPA. This is the Central Planning Authority. And with the Central Planning Authority, they also control the price. So the number of bags demanded is what they supply, is what is being produced. So they basically control the factors of production. That is land, labor, capital. So communism is basically that. And with this also you find that in Nyanza, the rate of consumption, presumably in Nyanza and Western, the rate of consumption of maize may be slightly higher than the rate of consumption of maize in Central Province. Therefore, you can see there's some fluctuations already. So if we say that we take 200 bags to Nyanza and 200 bags to Central for consumption, the people in Nyanza and Western may complete these 200 bags within no minute. And being from Nyanza, I can attest to that because of how I consume maize in my house. So because of that, there will be fluctuation in the production, in the market. There will be fluctuation in the market. So with Marx in place, the idea of communism was coming into being. Basically, the production is given to the government to control it. Then we go a little bit to capitalism. In capitalism, it's so clear that with the capitalist, it is assumed or it is said that generally human beings are inherently selfish by nature. So when human beings are inherently selfish by nature, what do? The government says that Babu has come up that he wants to produce something because of his selfish interest, or a person X within the government wants to produce something. So he comes up, Babu now produces like 200 bags of maize to meet the demand. Or other Babus or people, farmers, let me talk about farmers. They decide that we 10 farmers, we want to produce 1 million bags. How do we produce 1 million bags? Everybody is divided to produce a specific quantity. Then during the production, they say that, okay, because we are producing little fast, the demand for these bags becomes high. Therefore, the price goes high. Then the more they make money, the selfish interest again, they say that again, Babu, let us also produce more bags, more number of bags. Then the production increases. As the production increases, we find that as the production increases, the government leaves the people just to produce more and more bags. So there will be the invisible hand, because the government believes that the market, the demand and the supply will be controlled by the invisible hand. Automatically, whatever happens, even if we don't control it directly as a government, if we don't go so much into this level of production, then the invisible hands will automatically control the demand and the supply. So because of that, it is based on capitalism. So in capitalism, we have somebody called Adam Smith. Adam Smith, if you want to know more about capitalism, he wrote a book called Wealth of Nations. And Adam Smith stated clearly that it is not by the benevolence of the butcher or a baker or a brewer that we shall have our dinner, that we shall get our dinner. But it is in regard to their own interest that we shall get that dinner. So that was stated by Adam Smith. Adam Smith and Thomas Malthus are almost age sets. They were existing during almost the same period. So because of capitalism, you will see that in capitalism market, at least there's a cyclic nature. There's a cyclic nature how the production and the consumption behaves. So because of this cyclic nature, the government just comes in a little bit and says, let us just put a little control, but we should not tamper or interfere with the whole system, because everything else shall be controlled by the invisible hands. So because of this cyclic nature, because of this uncertainty, we need differentiation to handle and to come up with a solution on this. So generally, differentiation, we've said that it is the rate of change of quantities or functions. What are these functions? Let's go back now to mathematics. That was a little bit of history. But I need to explain to you more of history in this plus the mathematics so that you fully understand why you are doing this unit. So we want to talk about functions. So there are various types of functions. The first type of functions are linear functions. Linear functions are in the form of y is equal to mx plus c. We are very well conversant with this type of an equation. Mx plus c, where m is the gradient, c is a constant, x and y are variables. This linear function is monopolistic in nature. Why do we say monopolistic? Because the gradient is constant. At every specific point, the gradient is constant. So if we have a straight line graph, this is on a Cartesian plane, this is the x-axis, y-axis. So the gradient at this point is the same as the gradient at this point, is the same as the gradient at this point, is the same as gradient at that point. So we simply say that the gradient in this function is monopolistic. It is constant, it is certain. So we want to study certain functions which are uncertain. Number two, we will deal with polynomials as a function. Polynomial functions. Polynomial functions are in the form of p of x is equal to, a plus ax plus ax2 all the way to an xn. These are polynomial functions. Other polynomial functions, we have functions like the quadratic equation, that is ax squared plus bx plus c, which is a constant, equals to 0. This is a polynomial function. So we want to see certain curves of polynomials. So a curve like y, a function is written in the form of f of x, which can be equated to y, which is equal to 1 over x. This is a polynomial function. And also we can have f of x equals to 1 over, sorry class. This is x squared, y equals to x squared, and this is y f of x equals to y, which is equal to x plus 1 squared. And the third one, this is the first one, second one, third one is f of x equals to y, which is equal to x minus 1 squared. These are polynomials. So how do we plot them on a Cartesian plane? Because we still want to, later on we will find the gradients, we will find the differentiation, we will, from the uncertainty of these curves. So if we want to plot a graph of y is equal to x squared. So if this is our Cartesian plane, this is the x-axis, and this is the y-axis. So graph of y is equal to x squared when you plot it. This is a point 0, 0. So this is y is equal to x squared. So if you just come up with a table x, y. So when x is 0, y is 0. Just replace here. When x is 1, y is 1. When x is 2, y is 4. And when x is negative 1, x, y. When x is negative 1, y is 1. When x is negative 2, y is 4. When x is negative 3, y is 9. So when you plot this on a Cartesian plane, you will find this curve. Then we go to the next one. On a Cartesian plane, y is equal to x plus 1 squared. X-axis, y-axis. X plus 1 squared is this curve. At negative 1, 0. So this is y is equal to x plus 1 squared. Then x minus 1 squared x, y. This is at 1, 0 at this point. This is a point called the minimum point, the minima, or the minimum point. So at this point, this is y is equal to x minus 1 squared. So these are the polynomial curves. So these curves, I will tell you how we find their differentiation, how we differentiate them, how we find their gradients. So another function is the quotient function. Quotient function. So quotient functions, h of x is given by f of x over g of x. This is a quotient function. Quotient function can be y equals to 1 over x or y equals to 1 over x squared. Very fast, without wasting time, how do we get the curves for this? X-axis, y-axis, y, x. So for y is equal to 1 over x, this is the curve. So this is a curve of y equals to 1 over x. Then y equals to 1 over x squared, this is the curve. Y equals to 1 over x squared. So at the university level, this one you can simply, I'm oversimplifying these curves because this one is easy. You just plot it on a Cartesian plane. You draw a table. For every value of x, you replace with, and you get value of y. And then you just plot it. So this is what you'll get. Y is equal to 1 over x, and y is equal to 1 over x squared. Another function. Remember, we are still dealing with functions. So I just want to list all of them first. The fourth function is absolute value function. Absolute value functions are in the form of f of x equals to the modulus of x. Modulus means you square it and find the square root. So such type of a curve is that y equals to x modulus. This sign means modulus. Very fast. Another one is greater and least functions. They are given in the form of f of x equals to x greater, or f of x equals to x least. So These are functions which are discontinuous in nature. X-axis, Y-axis. So this is how they behave. They are open from this side and closed from this side. This is f of x equals to x, that. Then they also behave the same way. Closed. So they are continuous, they are discontinuous in nature. So these are greater and least functions. Other functions that we have, number 6, are transcendental functions. I need you to pay close attention here, class. Transcend, from the word transcend, transcendental functions. Transcendental functions, number 1, are functions like the trigonometric functions. And in trigonometric functions, we have the sine, we have the cosine, we have the tangent. In trigonometric functions, if I can give you a brief history of trigonometry, trigonometry was discovered by a man called Hipparchus. Hipparchus, he came from a place called Nicaea. Why am I interested in naming where he even came from? Nicaea or Nicaea, this is a place, it was a city. It is a city within the modern Turkey as we speak. So why do we remember Nicaea? Nicaea is greatly remembered because it constituted a council that came up with the establishment of the establishment of the somehow of the Holy Trinity. It did not establish it because from the biblical, from the creation theory, it is God who came up with this. But when a council was set up, they affirmed, let me use that word, they affirmed the Holy Trinity, that there exists God the Father, God the Son, and God the Holy Spirit, and that God the Son is the incarnation of Jesus Christ. That is why I'm interested in this city, and one day I hope we will visit it, comrades. So this is the man who discovered trigonometry. So in trigonometric functions, we have a graph of y is equal to sine x. How do we plot this curve? These are curves. So this curve so number 1, all these must be the same. They move the same. If you plotted this on a graph paper, this must be the same. Okay? So this is y is equal to sine x. This is x-axis. This is y-axis. Then the distance from here to here. Engineers, you will agree with me that this is called the amplitude. And the distance from here to here is called the period. Period is one complete cycle, a complete cycle, complete cycle. This graph passes from origin, which is 0, 0. Then we also have a graph of y. This is x-axis, y-axis. A graph of y equals to cos x. So again, this is what we call the amplitude. And this is what we call the period. So this is, again, it is very important. What I'm trying to build up to come to differentiation because of this uncertainty, the nature of these curves, how they behave. So next, we have under the transcendental functions, we also have the exponential functions. Exponential functions are in the form of ex and their inverses. Their inverses are called the natural logarithm function, natural logarithm functions, which you call the ln. Class, this is also interesting to know. Here also there's a little bit of history because every other thing was developed by somebody. Somebody came up with it. So in this situation, there were two gentlemen who came up with the exponential functions and the natural logarithm functions. The first gentleman is called John Napier. And the next gentleman is called Just Bourgi. John Napier developed logarithms using algebra. He developed logarithms from algebra, while Just Bourgi developed logarithms using geometry. This one now at the university level, you must know this because we must have content. It's not just about going to class. Comrades, there's a difference between going to the university or rather walking through the university and the university walking through you. Passing through the university and the university passing through you. You will tell me that difference later on. So we need to have content. As a lover of maths, I must know this, and as a lover of mathematics, you must know this. So when we go to the exponential functions, very fast, we just want to get their curves. X-axis, y-axis. So an exponential function, this is y is equal to e of x. This is an exponential curve. And you've been hearing the Cabinet Secretary Health, Bwana Mutai Kagwe, CS Mutai Kagwe, has been saying that coronavirus is increasing exponentially. What does he mean? What he means is so simple, that as the curve grows larger, the value of x increases. So as the value of x increases, the curve tends to grow larger. As the more number of people are tested, we tend to get many infections. So this is an exponential curve. This curve must never touch the x-axis. It will draw very close to the x-axis, but it should not touch the x-axis. The moment it touches the x-axis, the value of y becomes 0, and that can never happen. So coronavirus is growing exponentially in the whole globe. Alternatively, this is x-axis, y-axis. The natural log, the ln function, its curve is like this. Y is equal to ln x. You will say ln x, ln x. So one is the mirror image of the other. One is the mirror image of the other. If you want to combine them, if you like, this is an exponential curve, ex, and this is a natural log curve, ln of x, and this is the line of y equals to x, the mirror. This is a mirror image of the other one. So very fast, from there now we get to the real thing, that is differentiation. So we will go to the methods of differentiation. Differentiation. So methods of differentiation. Number one, this is where now I need you to hang on my lips. And I will want you to comment with your numbers at this particular point so that I have a team that is going to send you airtime. The first 500 people who will comment with their numbers will get free airtime. Immediately you'll be sent airtime. So let's get to work. Methods of differentiation. Number one, the power rule. Power rule, we know this from high school. Power rule is in the form of x raised to power n. And there's a little history about power rule. Power rule was discovered by a person called Leibniz. Leibniz was a researcher. Leibniz was doing research on different things. Leibniz is considered to have been greater than Isaac Newton. The only difference between Leibniz and Isaac Newton is that Isaac Newton specialized only in science, but Leibniz was doing research on many different topics, on many things. One day, Isaac Newton was walking along the streets and people shouted, "Oh, Isaac Newton, the great man." Isaac Newton said that I'm not a great man. I'm only standing on the shoulders of giants. Himself, he said that he was only standing on the shoulders of giants. Although he was a very little man, still considered as a great man. And who are these giants that Isaac Newton was standing on their shoulders? Number one giant was Kepler's. Number two giant was Pythagoras. Number three giant was Leibniz. Number four giant was the Archimedes. Archimedes, engineers, you'll agree, he came up with a principle called the Archimedes principle. Archimedes principle, when we look at the law of flotation, those studying engineering, Archimedes principle states that when a body is fully or partially immersed in a fluid, it experiences an upthrust or an upward force or a loss in weight, which is equivalent to or congruent to the weight of the fluid displaced. I hope you've heard that. I want to repeat. Archimedes principle states that when a body is fully or partially immersed in a fluid, it experiences an upthrust force, or an upward force, or a loss in weight which is equivalent to the weight of the fluid displaced. So we know about Archimedes. Back to power rule. Power rule, if you are given a function of f of x equals to x raised to power n, how do we differentiate this? The differential of f of x is written as f prime of x, or written as y prime, or written as dy dx. You don't say dy over dx, you just say dy dx is equal to, when you want to differentiate this, bring down the power n, maintain x, then n minus 1. First example, differentiate 4x squared. You say dy dx equals to, dy dx equals to, bring down 2, multiply by 4, then x raised to power 2 minus 1. This comes to 8x raised to power 1, which is also written as 8x. Number 2, differentiate 4x cubed plus 3x squared plus x minus 1. So when we differentiate this, bring down 3, multiply by 4, then x, 3, subtract 1, plus, bring down 2, multiply by 3, then x, 2 minus 1, plus, this is x raised to power 1, bring down 1, multiply by x into 1 minus 1. Then this is a number, when you differentiate it, is 0, because there is a silent x raised to power 0 here. So when you drop this 0 down, it becomes 0, then x, 0 minus 1. Any number multiplied by 0, so this takes 0. So our answer here is 12x squared plus 6x plus 1. We are done with the power rule. The next method of differentiation is the product rule. When we are dealing with the product rule, we deal with a product of two functions. So if you are given an example of f of x equals to x squared minus 1 times 3x cubed plus 2x, let's say that. When you are given such a function, this is a product of two functions. So use product rule. Number 1, let this first value be u, second value be v. First value be u, second value be v. So u equals to x squared minus 1, where v equals to 3x cubed plus 2x. Therefore, du dx differentiate with respect to x. Differentiate the function with respect to x. We say du dx equals to, bring down 2, differentiate this becomes 2x. Here is dv dx equals to, bring this down becomes 27x squared plus 2. Therefore, by product rule, you say dy dx equals to v u differentiated plus uv differentiated. So the value of v, keep it constant, differentiate u, add to the value of u constant, then v differentiated. So in our case, our value of v is this, which is 3x cubed plus 2x times the value of u differentiated. U is du dx. From here, u is du dx, so it is 2x plus value of u is x squared minus 1 times v differentiated. V differentiated is dv dx, which is 27x squared plus 2. Then open the bracket very fast, you simplify. 2 times this is 6x raised to power 4 plus 4x squared plus, when you open this up, is x squared into 27x squared plus 2 minus 1 into 27x squared plus 2. So this becomes, this times this is 27x raised to power 4 plus 2x squared minus 27x squared minus 2. So collect the like terms. We have x raised to power 4 and x raised to power 4. This comes to 33 x raised to power 4. And then we have x squared. This times this is 27 power 4. This times this is squared. This times this, good. So we have x squared here, and we have x squared here, and we have x squared here. So 4x squared plus 2x squared is 6x squared minus 27x squared is minus 21x squared. Then we have minus 2. So that is our answer. Dy dx equals to 33x raised to power 4 minus 21x squared minus 2. So simply in product rule, you just multiply, you just come up with the formula for dy dx. which is equal to v u plus u v differentiated. V u differentiated plus u v differentiated. This is what you need to know. Where your first function is u, the next function is v. So you can have like x squared minus 1 times x cubed plus 1. So this is u, this is v. So equate this as u equals to x squared minus 1, then v equals to x cubed plus 1. Then du dx equals to 2x, dv dx equals to 3x squared when you differentiate this. Then dy dx equals to v u, where is value of v? V is this, x cubed plus 1, then times u differentiated, that is 2x, which is here, du dx, plus u is x squared minus 1, times v differentiated, which is dv dx, 3x squared. Then you open the bracket, this becomes 2x raised to power 4 plus 2x. Then this becomes plus 3x raised to power 4 minus 3x squared. So x power 4 and x power 4 becomes 5x power 4. Then minus 3x squared plus 2x. That's it. So we go to quotient rule. We go to quotient rule. So quotient rule, we said that if you have a function of h of x is equal to f of x over g of x. Suppose we have a function like x cubed plus 2x plus 1 divided by x squared plus 2. Use quotient rule to differentiate this function. So number one thing I said, be consistent, let this be u, then this value be v. So you say u equals to x cubed plus 2x plus 1, whereas v equals to x squared plus 2. Therefore, just get du dx. Du dx with reference to x. When you differentiate this, you get 3x squared plus 2. While this side is dv dx, you get 2x. Therefore, by quotient rule, dy dx equals to vu differentiated minus uv differentiated over v squared. You also need to know this, very important. Just make sure you identify the first value alphabetically, uv. They follow in that order. Then when you come here, you just reverse it. V comes first, then u differentiated minus u, v differentiated over v squared. So in our case, we have v. What is our value for v? Is here, which is x squared plus 2, times u differentiated is du dx, which is 3x squared plus 2, minus u, which is here, x cubed plus 2x plus 1. Then v differentiated is 2x divided by v squared. Our v squared is x squared plus 2. Then you square it. So when we open this very fast, what do we get? X squared times this is 3x raised to power 4. Then this times this is plus 2x squared plus 6x squared plus 4 minus this side is 2x raised to power 4 minus 4x squared minus 2x. So what do we get here? Remember, it's over this. So what do we get here? We collect the like terms, this and this. You get x raised to power 4, then this and this and this. 2 plus 6 is 8x squared. 2x squared plus 6x squared is 8x squared minus 4x squared is 4x squared. Then we have this minus 2x, then plus 4. Divide by x squared plus 2, everything squared. This is our value for dy dx. So this is the quotient rule. So in quotient rule is so simple. Just master this formula. Dy dx is equal to v constant, keep v a constant, differentiate u. Then minus, subtract u constant, differentiate v. Then divide by v squared. And then you just work out your expressions. You be very careful with the signs here, but I hope this is a very legit answer. So you can be given many functions. Let's try a normal one that you always know. They say tan x equals to sec squared x. Prove. If you are given such a question, prove that the differential of tan x equals to sec squared x. Prove that tan x differentiated equals to sec squared x. If you're given such a thing, just smile, take a lollipop if you can. Now you come here, solution, tan x equals to, normally tan x equals to sin x divided by cos x. Tan x equals to sin x divided by cos x. So let sin x be equal to u. So u equals to sin x, where v, we use quotient rule because this is, we use quotient rule when we have two functions which are being divided. So cos x equals to, v equals to cos x. Then du dx equals to, when you differentiate sin x, you get cos x. Then on this side, dv dx, when you differentiate cos x, you get negative sin x. Then write your normal formula of quotient rule. Vu minus uv differentiated, vu differentiated minus uv differentiated over v squared. So in our case, our v here is cos x times u differentiated is du dx, which is cos x, minus u, our u here is sin x, times v differentiated is dv dx, which is minus sin x, divide by v squared, which is cos x squared, which is written as cos squared x. So you open up, cos squared times cos squared is cos squared x. Oh, cos squared x. Then minus times minus is plus. Then sin x times sin x is sin squared x. Divide by cos squared x. Divide by cos squared x. So from here, the rules of trigonometric identities, cos squared x plus sin squared x is equal to 1. Then divide by cos squared x. 1 over cos squared x is the same as sec squared x. So when you prove, you put that sign to show that you've proven. Clear? Now we go to another rule called the chain rule. Class, we are almost through. Just in a few after the chain rule, we go to transcendental functions, then we will be done. So chain rule. Some people baptize it as Jacobian chain rule or Jacobian chain rule, depending on where you came from, or Jacobo if you came from where I came from. So the chain rule is a very simple rule. It's a simple method of differentiation. So we'll just handle examples and I will tell you how it flows. Number one, if you're given a function of x raised to power 4 minus 2x squared plus 2x plus 1 raised to power 10, you are told to differentiate using chain rule. So using chain rule, the first rule you do, let u. Remember, in all this thing we are just using u and v. So let u be equal to this function, which is x raised to power 4 minus 2x squared plus 2x plus 1. So if our function is f of x or y equals to this, then u is equal to this. What about very fast du? Just get du dx. Du dx here is 4x cubed. Just differentiate this. Becomes 4x cubed minus 4x plus 2. If you differentiate, you just bring down the power, then you lessen it by 1. Bring down the power, multiply by the coefficient, lessen by 1. So this is du dx. Then our initial function y equals to, if we let the whole of this to be u, so we just say u raised to power 10. Therefore, from here also you get dy du equals to, differentiate this, you get 10u raised to power 9. Therefore, dy dx, be keen here class, dy dx. Remember, we just let this to be equal to u. Then we differentiated it to get du dx. Then we just rewrote this equation as y equals to this value raised to power 10. But this value we said it to be equal to u. So it's the same as y equals to u raised to power 10. Then again we got dy with respect to u. You differentiate this. So you got 10, we get 10u raised to power 9. So 10u raised to power 9. Therefore, dy dx equals to dy du times du dx. This is just playing around with these differentials, with these letters. dy dx equals to dy du times du dx, such that you can easily cancel du and du, so that you remain with dy dx, which is this dy dx. Class again, dy dx equals to dy du times du dx. So you can easily cancel du and du. You remain with dy dx. So writing dy dx in this form is just the same as writing dy du times du dx. So what is our dy du? Our dy du is this. Just replace 10u raised to power 9 times du dx. Our du dx is this, 4x cubed minus 4x plus 2. But we want our answer in form of x. So we have u. So you just substitute 10. Our u, initially we said let our u be equal to this. So just replace this with u, which is x raised to power 4 minus 2x squared plus 2x plus 1. But it is raised to power 9. Then this you multiply by du dx, which is 4x cubed minus 4x plus 2. And that's our answer for the chain rule. Very simple. We take one more example, chain rule, then we go to transcendental functions. One more example in chain rule. Find dy dx or f of x prime or y prime in the equation f of x equals to x raised to power 4 minus 3x plus 2 raised to power 7. Class, very simple. The first thing you do, let u be equal to this value which is inside here, which is x raised to power 4 minus 3x plus 2. Therefore, du dx equals to du with reference to x equals to 4x cubed minus 3. At the same time, remember, we want to get dy du. So we have our y value being equal to, we said the whole of this is u, so just put it as u, but it is raised to power 7. Therefore, dy du equals to, differentiate this, 7u raised to power 6. So come here and write dy dx. By chain rule, dy dx equals to dy du. Then u comes up, du dx, so that you can get dy dx. So dy du is 7u raised to power 6 times du dx is 4x cubed minus 3. But we want to replace, we only substitute u so that we get our answers in form of x, because we want dy dx x. So 7, but our u is here, x raised to power 4 minus 3x plus 2. But it is raised to power 6 times, the value here is 4x cubed minus 3. That is by chain rule. Next class, the last one, the last functions, transcendental functions. Transcendental functions. Transcendental functions. After this, we just go to implicit functions, then we shall be done. So in the next 10 minutes, we'll be done. So don't worry. Transcendental functions, we have functions like sin x, cos x, that is the trigonometric functions, the exponential functions and their inverses, which is the natural log functions. So let's start with the trigonometric functions, trig functions. In trigonometric functions, you can be given an equation of f of x or equals to y, which equals to, you are told to differentiate cos 2x. Very simple, class. Just use the let u be equal to, what is inside here is 2x. Then du dx equals to, differentiate this, you get 2. We will differentiate this using chain rule. Then at the same time, y equals to cos, but 2x we said is u. Therefore, dy du equals to, cosine of u is negative sine u when you differentiate. So class, this is also by chain rule. Now when you come to by chain rule, dy dx equals to dy du times du dx. Dy du is negative sine of u times du dx is 2. So here is negative 2 when you simplify, negative 2 sine of u. But what is our u? You just replace. So negative 2 sine of u. Our u, we said, is 2x. So this is our answer. Simple. If you don't want to go through the whole of this method, you can just say y is equal to cos 2x. Y equals to cos 2x. What do? I write y prime, which is dy dx, equals to, maintain the whole of this. Just differentiate cosine, you get negative sine. So when you differentiate cos 2x, you get negative sine 2x. Then multiply everything by the inside differentiated, which is 2. So dy dx equals to negative 2 sine 2x. This is just one step. But this one now for you to get full marks. So you can do it using this method for the chain rule. Then you just say you differentiate this function multiplied by the inside differentiated. So another example. Another example, let's say y equals to 1 plus cos 3x squared. 1 plus cos 3x squared. The first thing, let u be equal to 1. What is inside here? 1 plus cos 3x. Therefore, du dx, when you differentiate 1 is 0. When you differentiate this, you get negative sign, the same thing, multiply by the inside differentiated, which is 3. 3x differentiated is 3. So this will give you negative 3 sine 3x. But we have two parts. This side we have y equals to, we said this is u. So u raised to power 2. Therefore, dy du equals to, differentiate this, you get 2u. So just join by chain rule. Dy dx equals to dy du times du dx. So dy du is 2u times du dx is minus 3 sine 3x. So open this from here. 2 times 3 is minus 2 times minus 3 is minus 6 u sine 3x. So dy dx equals to minus 6, but u, just substitute the value of u here, is 1 plus cos 3x, then sine 3x. Very simple. That's our answer for that. Now we go to exponential functions. Before I go to that, let me try an inverse of a trigonometry. Class, these are now the setting points. University students, such questions, lecturers, sometimes they become fishy and they like setting them. So pay close attention. If you are told y equals to sine inverse of x, find the derivative. Find the derivative of this, derivative. In other words, derive or differentiate. So in this case, don't panic. Just write this equation afresh. When you write y is equal to sine inverse of x, is the same as writing x equals to sine y. Then very fast, just from there, without moving, get dx dy equals to, when you differentiate sine y, you get cos y. Okay? But we want dy dx, not dx dy. So you can't say 1 over this. You want dy dx, not dx dy. So you remember in your high school you are taught something called SOHCAHTOA. SOHCAHTOA, you had a right angle triangle. So SOHCAHTOA, sine is equal to opposite over hypotenuse. Cos is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. So in this case, we are dealing with here, sine y. So if our y is here, our angle y is there, we get opposite over hypotenuse. So what is our opposite? Is x. Here, what is our hypotenuse? It is x over 1. So hypotenuse is 1. So how do we get the adjacent? Is hypotenuse squared minus opposite squared into the square root. Therefore, now we want cos y. So cos y equals to, cosine is adjacent, which is this, 1 minus x squared, the square root, over hypotenuse, which is 1. So when you come to your answer, dx dy equals to cos y, but cos y equals to 1 minus x squared. Square root means raised to power half. Okay? Over 1. So, what is our dy dx? Dy dx, just get the inverse. Just change. Just reverse this. 1 over 1 minus x squared raised to power a half. Be careful. When you are given the inverses, you make sure you introduce SOHCAHTOA. First of all, just differentiate. This is differentiating x with reference to y. So this is dx dy, but we want dy dx. So follow that, you are home and dry. So next we go to exponential functions. We have few we are finishing. Just keep on following. This is where the setting point is. So exponential functions. You are told y equals to e3x squared. Differentiate. When you differentiate this, let u be equal to this value, 3x squared. Therefore, du dx equals to 6x. Then on this side, y equals to e. Then what is our u? 3x squared. So replace where 3x squared is with u. Then dy du equals to, when you differentiate an exponential function, e raised to power u is eu. E raised to power x is ex. So in our case is this. So by chain rule again, dy dx equals to dy du times du dx. So dy du, in our case dy du is eu times du dx, in our case is 6x. So what do we get? Eu 6x, but we replace u because we want dy dx. Dy dx. You get e, but what is our u? 3x squared multiplied by 6x. So if you want to write it beautifully, you write 6x e 3x squared. One more example on that. So a function like y equals to e 2x cubed plus 3x minus x plus 1. So here, let u be equal to this. That is 2x cubed plus 3x minus x plus 1. Therefore, du dx equals to, differentiate 6x squared plus 3 minus 1. Okay. Let's say this is squared. Because I want cubed squared, I just go to x. So this is 6. Let's say this is 6x minus 1. If you differentiate that. And on this side, we said y equals to e, but our u is this. So we just say e raised to power u. So dy du equals to e raised to power u. Therefore, dy dx equals to dy du times du dx. So this equals to dy du is here, e raised to power u times du dx is 6x squared plus 6x minus 1. So dy dx equals to, replace where u is, replace with this value, which is 2x cubed plus 3x squared minus x plus 1. Then this, you just replace this, which is 6x squared. You don't replace, but just write it there, 6x squared plus 6x minus 1. And that is our answer. So if I want to oversimplify this, what I do, I just say if I'm given this function, then my dy dx from here, I just let this remain. Simplified over simplified, dy dx equals to, I let this remain, which is e 2x cubed plus 3x squared minus x plus 1. Then times this differentiated. This differentiated is 6x squared plus 6x minus 1. One step and you have your answer. My pens are running dry, but it's okay. Now we go to natural logarithms. The third one, you are given differentiate ln x. Ln x, when you differentiate, is 1 over x. When you are told to differentiate ln x squared plus 2x, this is another one. Just let u be equal to this, which is x squared plus 2x. Therefore, du dx equals to 2x plus 2. And then on this side, we said y equals to, this is replaced by u. So y is equal to ln u. Therefore, dy du equals to 1 over u. So you just come here and say dy dx equals to dy du times du dx. So what is dy du? Dy du is 1 over u times du dx is 2x plus 2. So here you get 2x plus 2, but you replace value for u. What is our u? Is this, which is x squared plus 2x. Finish. Can we further simplify this? 2 into x plus 1, x into x plus 2. Okay, that's like that. So the ln functions, the only secret is let u be equal to this. Then chain rule, you apply chain rule, you get your answer. Now the last one is implicit functions. Implicit functions. Now implicit functions are functions like the equations of a circle. Equation of a circle. If you are told that a circle, an equation of a circle is x squared plus y squared is equal to 25. This means that this circle has a radius of 5. Just get the square root of 25, you get 5. With a center 0, 0. So you are told that the equation of a circle is this, at a point 0, 0, with a radius of 5 units. Find the derivative. Find dy dx of this. Be keen here, class. What you do, separate this and differentiate them individually. So they want dy with respect to x, So dy dx, because he has x, just differentiate it normally, write 2x plus y squared, differentiate normally, write 2y. But because we are not differentiating x here with respect to x, just introduce dy dx. Then equals to, when you differentiate 25 is 0. So 2x plus 2y dy dx equals to 0. Then make dy dx the subject of the formula. So 2y dy dx equals to, when 2x crosses the other side becomes negative, 2x. Then divide by 2y, divide by 2y. So dy dx equals to, when you simplify this, is that, minus x over y. So if you are told to find the value of dy dx at a point 0, 0, 0, 0 means value of x is 0 and y is 0. So you just replace x 0, y 0, you get 0. At a point 4, 3, just replace x as 3, y as 4. You get 4 minus 4 over 3. So again, the last example, you are given equation of a circle as 2x squared plus 3y squared equals to 4. At a point, this one is just an example, at a point of point where x is 2, 3. The coordinates are 2 and 3. So get the dy dx. Dy dx equals to, differentiate this, normally because it has x, becomes 4x plus differentiate where there is y, because we are differentiating with respect to x. So where there is y, just differentiate. Normally you get 6y, but introduce dy dx equals to 0. When you differentiate 4, you get 0. So make dy dx the subject of the formula. 6y dy dx equals to minus 4x. Then divide by 6y, divide by 6y. So dy dx equals to, when you simplify this, you get minus 2 over 3 x over, minus 2 over 3 x over 3y. So at this point, just replace the value of x and y. So when x is 2, just come here and write minus 2, x is 2, replace 2. Divide by 3, y is 3, write 3. It can be 10, 12, 1, 2, 0, 0, just replace the value of x and y. So this comes to minus 4 over 9. So class, today, that is how we end our lesson. I hope you enjoyed your lesson and it changed your life. I'm still with you. Next week, I'll be dealing with the KCSE students. I want to ensure that our KCSE students join our comrades at the university, so that at least their lives are changed. I want to read some few comments from our people. Paul Korir, Babu, next time unapewa treasury. Huyu anataka niwe CS, asante sana. Tahakikisha pesa yenu iko na kwa usalama. Eli Obado, bundles mheshimiwa, please tumia huyo Eli 07. Okay, I'll give you the number. I don't want to expose it. George Wangige, better. This is great class. Congratulations, Prof from Florence. Crispin Okoth. But we are this one of the politicians. But X can try PE. I don't want to say the name. Okay, it's YT too. Did I mention his name? It's okay. Juando Bran. Great work, Prof. Abdullahi. Prof uko juu sana. I'm watching from Washington, D.C. This is great work. It has changed the life of my child. This is Facebook. Huh? Cherono. Hey, next time we try also another one. This is really making my life easier at the university. I'm an engineering student from Luke Mbogo. I love your brain. Wow. I also love my brain. Thank you very much. Lillian, Lilies, calculus 2 and 3. We'll handle that. Don't worry. Eric Moindi, good work, Mwesh. It's okay. Comments ziko hapo kwa wingi, ziko poa. Marieta Wanyama, I miss mathematics class after your lesson. It's okay. This is YouTube. Paul Michael, Babu Tibim, Kibet, Kibenei, thank you mheshimiwa. Domi, I feel like trying, Prof. This is great work. Wacha homework. Okay. Wacha niwawachie homework moja. Huyo anataka homework. Try this. Find the derivative of y is equal to this. Very easy. Y is equal to just try those ones. So Green Cross Lawrence, I'm from Rongai. I love math. This is great. Babu, you've changed my life. Charity Ngilu. Oi. Okay. Asante sana mheshimiwa. Umesema Babu, we love you. This is great. Changing the lives of my constituents. What a talent, Kennedy Ochola. Moses Kigano. Babu, tunakutaka huku Central, huko top kabisa. Hata ukivai huku tutakupatia bure. This is nice. Asanteni sana. There are so many comments. Again, Charity Ngilu, thanks honorable. Ann Kiguta, leo umepatikana. Mheshimiwa, hizi hesabu hata sikusikia hata kidogo. Nimeshinda nikilala darasani. But tutakutana tena punchline. Tibim. This is Instagram. Victor Sadera, mwalimu asante. Samuel, This is great. Makush, hello mheshimiwa. I'm a student at Pwani University. Nilifungiwa huku Kilifi. Oh, comrade, hit my inbox nikupangie kazi kidogo bro. It's Boke. Thank you so much Babu. Korir, Babu, this is great. We love you in Rift Valley. In fact, mama president. Stakis president sahi. Sahi tunapatia baba kwanza awe rais. Nimo Sheikh. Hi Babu, we love you all the way from Northeastern. Mimi ni president wa Kuso. Tunakupenda sana. Babu, tear gas. Hey. Edith Mwirigi. Wise man, this is great. I love what you are doing. You are helping our children. Wow. Thank you. Thank you my fans. I love you all. God bless you all. Tuko pamoja. Tibim.